Actually, I just did it for the morning, and the recording you can still see it there. So now, just like the previous two tutorial, I'm not going through that worked out sample because here it is worked out, and I believe that you have tried and you understood. If you don't, then please point out. And these are the answers are given here. Some of the self-testing questions are very straightforward. There is only one answer, you know, but some can be confusing. So first one, Bronsted-Lowry acid and base, right? What is Bronsted and Lowry acid and base? That is the thing we have to know first. Bronsted-Lowry acid and base is whichever species can donate proton, that is hydrogen ion. Hydrogen ion is also called as proton because there is only one electron. So if electron goes out, only proton left in the hydrogen atom. So it is called hydrogen. So those species that can donate one hydrogen ion, that is an acid, and whichever takes it, that is a base. So acid and base, that is pretty much what by this Bronsted and Lowry. There are other two definition of acid and base. Which one is that is one is Arrhenius. Arrhenius is one of the earlier one, and there is a Lewis one also. But for us, Bronsted-Lowry will serve our purpose. So in the question asking, in which of the reaction is water acting as a Bronsted and Lowry base? So in which of these A, B, C, D, water is taking one hydrogen, right? So here we see that HCl is giving one hydrogen ion or or proton to this, and water becomes H3O plus, right? So this is called water is taking the hydrogen ion. So here it is hydrogen ion. Water in this case, water is acting as an acid, base, okay, because it's taking the hydrogen ion. And in B, what is happening? Hydrogen, water, and sulfur trioxide gas, most probably it is gas, let's say, that water and sulfur trioxide gas, H2O, right? So this H2O is giving up one hydrogen first, giving up one hydrogen and hydroxyl, right? Hydrogen and hydroxyl. So this hydrogen ion that is given up by water, it will first bonded to this SO3. It will first bond to the SO3, then it will form HSO3. Okay, HSO3 -1. All right, so this is how, and afterwards this hydroxyl again, it will bind to this HSO3, and it will produce H2SO4, and then there will be no charge. So in this way, that means water is actually giving a proton or hydrogen ion to sulfur trioxide. So, and that is how they are producing H2SO4. So in this case, water is an acid. Same goes for BC. Water is giving up one hydrogen or proton to ammonia, and it is producing ammonium ion, right? D is H2O. D and B are the similar mechanism is going on, and here also this is at the end, it is producing H2CO3, that is the bicarbonic acid. Carbonic acid, sorry. All right, so now question number 2. In which of the following reactions is the first reactant acting as an acid? First reactant is this one. All those are the first reactant, and these are the second reactant. If there were plus anything here, then that would be third reactant, right? So this is called first and second reactant. This is how we differentiate. We started from, for question number 1, we started from A. For question number 2, we started from D. Let's see where you get the answer. So, in which of the following reaction is the first acting as an acid? Acid, that means it is supposed to take a hydrogen ion or proton. So, here, does it take a hydrogen ion? Or, sorry, whichever is supposed to give a hydrogen ion. So, in this case, HCl is giving a hydrogen ion to this HSO4, right? So that means this is not an acid, rather it's a base because it is taking a hydrogen ion. C, same thing is happening. It is taking the hydrogen from the water and it is producing carbonic acid. B is same thing, right? B is also the same thing. Nitric acid is giving hydrogen to this biphosphate. And A, although this A and B, the first reactant are same, right? Although they are same, but here in A, it is more acidic than water. That is why it is giving the hydrogen to the water. And that is why it is the right answer and acting as an acid. But even though the same species HPO42 for option B, it is not acting as an acid. It is acting as a base rather. Okay. Question number 3. A 1 molar standard solution of sodium hydroxide is used to analyze the concentration of hydrochloric acid in brick cleaner. The sodium hydroxide is called a standard solution. Why? Why do we need to call it a standard solution? Okay, it is mind it is not calling the primary standard, secondary standard. It's an standard solution because we prepared the sample. We ourselves prepared the same thing, isn't it? We ourselves did it. So we know exactly how much. We wanted to make 1 molar sodium hydroxide standard solution, and at the end probably we standardized it against a standard, or we calibrated it against a standard solution, so we exactly know what is the concentration of this sodium hydroxide. So that is why it is called the standard solution. That means we know, we are very confident of the concentration of the solution. So the concentration of the solution is accurately known for this. Question number 4. Properties of primary standard for the use in acid-base titration include all of the below except 1. Primary standard should be high molar mass and inexpensive. It should be high purity and a known formula. It should not be high, it should have a high stability and shouldn't be a delinquent, or should not absorb air, water from the air. And so this is, all 3 are the characteristic of standard, primary standard. But this 4, if it is present in those any of the compound, it cannot be considered as primary standard anymore. High reactivity to oxygen and low solubility in water, so it cannot be considered as a primary standard. Which of the following not suitable to be used as a primary standard? We know that sodium borate, although there are 18 moles of water in 1 mole of their atoms, okay? Sorry, one molecule of this, there are 18 molecules of water molecule there. So it is quite stable. It's very stable, sodium borate, and it can be used as a primary standard. Oxalic acid can be used as a primary standard. Potassium hydrogen phthalate can be used as a primary standard. But sulfuric acid, it is hygroscopic, okay? It is hygroscopic or delinquent. So it absorbs the moisture from the air, and that is why in the industrial level sulfuric acid is used as to remove moisture from the air. If the manufacturing needs a room where should not be very small, less amount of moisture should be there, so they use sulfuric acid. One of the method is to use sulfuric acid. Calculate the mass of sodium chloride present in 500 milliliter of 0.2 molar solution, 2 molar or 2 mole per liter solution. So the mass of sodium chloride I need to know. First of all, I have to know the number of moles of sodium chloride. That means N equals C into V, right? N equals C into V, okay? So in this case, concentration will be this number of moles and volume will be in liter. So we have to convert this volume in liter. That means we have to divide by 1000, and in that way it will be 0.5. So if we know the number of moles, okay, in this number of moles we know, and then we can just multiply it with the molecular weight or molar mass of HCl, and then we find the molecular weight, the mass of sodium chloride, and in this case it will be 5.845. Question number 7. When 2.3 gram of zinc nitrate is dissolved in enough water to make 0.5 liter of solution, the concentration of ions in the solution are. There are few things to note here. There is 2.37 gram of zinc nitrate, and we see it from here, the chemical formula. And luckily it is given that it dissociates in this way in the water, okay? And then it was made up to 0.5 liter, not even 1 liter, just 0.5 liter solution. The concentration of the solution, okay, and it is asking us for the concentration. Remember, it's not number of moles, but concentration. So what we have to find the concentration, what do we do? We will find the concentration by knowing the number of moles divided by the volume, right? So that we find the number of concentration. One thing to note here, that zinc nitrate, when it is dissociated or broken down from zinc nitrate, it is producing 1 zinc and 2 nitrate. Okay, 2 nitrate ion and 1 zinc ion. So what if X mole of zinc nitrate, X mole of zinc nitrate is there, X mole of zinc and twice X moles of nitrate will be there, right? So this is quite interesting, it is important to note. So now let's make the, how can we find the number of moles? 2.37 over the molar mass of zinc nitrate, 2.57. Zinc nitrate molar mass will be, zinc is, I forgot. Let me check. 65 is zinc, okay? 65 is zinc, and then nitrogen is, there are 2 nitrogens, okay? 1 zinc, 2 nitrogen, and 6 oxygen atoms here in zinc nitrate. Where do I write it? Okay, so here is 1 zinc, 2 nitrogen atoms, and 6 oxygen atoms are there. So if we sum up all their atomic mass together, it is not 60, it is oxygen, okay, together, then we will find zinc nitrate. Let me check again. Okay, so it will be 65. Anybody knows how many? Then I don't need to do it. 65, 60. Somebody answered. Zinc is 65.39. then I have to add up oxygen and nitrogen. So all together is how many? 189. Jonathan, thank you. 189. So if I 189 point something, 189.5 or something, so that I will find it is the constant number of moles for it will be 0.125, 0.0125 number of moles of zinc nitrate. Okay, this is zinc nitrate whole together, zinc nitrate all together. Okay, so now if I have this amount of zinc nitrate, I will have okay, so it's asking a number of moles. This is number of moles, but it is asking us the concentration, right? It is asking us the concentration. So how do we find the concentration? Divided by the volume, that is 0.5 liter. 0.5 liter, and that is how I will have 0.025 molar of zinc nitrate solution. And in that solution, I will have exactly that concentration of zinc, but since it is 2, it will be doubled. The nitrate ion will be doubled. Okay. Any question? All right. Question number 8. A solution was prepared by pipetting 5 milliliter of 18 molar sulfuric acid to a 500 milliliter volumetric flask and top up to the mark with deionized water. What is the concentration of sulfuric acid? Again, the concentration is asking, so I need to know the number of moles, right? Go straightforward. I need to know the number of moles. How do I know the number of moles? This is V and this is C. So N equals C into V. Again, N equals C into V. If we multiply these two, then we will get both together, we will 0.09, I think 0.09, yes, 0.09 number of moles we will get. So, and that is dissolved in 500 milliliters, so that means 0.5 liter, yeah. And in that case, it will be just doubled, 0.5, so 0.18. It will be 0.18, sorry, 0.18. This is 0.18 mole per liter or molar solution it will be. Okay, now it is much wider. When 50 milliliter of nitric acid solution is exactly neutralized by 150 milliliter of 0.5 molar solution of potassium hydroxide, what is the concentration of nitric acid? Now it is a titration question, right? This is a neutralization question, titration question. So we can easily use C1, V1, C2, V2. I don't know, I am sure that you know this, but probably you know it in another form, that is N1, M1, M2, M2, the same thing, C2, same thing. So this is the concentration of first solution, 1, volume of first solution, concentration of second solution, volume of second solution when they meet together and will become neutralized, or the dilution when we do the dilution. This factor, this formula is very important and very useful actually. So here it says that V1 is given, right? V1 is given by, this is a V2 and C2. So if I have C1, then what I will have, I mean, if I want to find the C1 here, because V1 is given but C1 is not, so I will divide these two by the volume V1, and of course the volume should be in liter. So from there we will find the concentration of this is 1.5 molar. 10. A 10 milliliter sample of vinegar contained ethanoic acid is made up to the mark with water in 250 milliliter volumetric flask. 20 milliliter aliquot are then titrated against this 0.2 molar sodium hydroxide. The average titer is 150, the reaction. So again, the same thing. We can do the C1, V1, C2, V2, and then we just multiply with this dilution factor, and I'm sure that you are already known about it. I mean, you are already familiar with it. So the dilution factor is 25 times here, and after we find the C1, right, from the C1, V1, C2, V2, or N1, V1, M1, I think there is N1, M1 is equal to N2, M2. Okay, M2, N2. So this is some students know by this formula, but this is the same thing actually. It's okay. This is the same thing. So from here we can find the C1 by using this formula, and after that we can just multiply with the dilution factor, that is 25 times here, and that would give us, I think it is let me check, 3.75. 3.75, that is C. Okay. Answer C. Okay. Question 11. To determine the concentration of ethanoic acid in a sample of vinegar, a 10 milliliter aliquot of the vinegar was made up to 100 milliliter in the volumetric flask, then titrated against 20 milliliter aliquots of the sodium hydroxide solution of concentration 0.099 molar. The equation goes in that way. The concentration of ethanoic acid in the vinegar was, what is the concentration? That means what is the mole per liter? Again, find the number of moles of sodium hydroxide, and then 1:1 reaction. This is the volume of sodium hydroxide. This is the number of concentration of the sodium hydroxide. So if we just multiply these two, of course it had to be converted to liter first, and then multiply with this, and we get the number of moles. It is exactly the same number of moles acetic acid, and it was diluted 10 times dilution, because 10 milliliter was made up to 100 milliliter, so that means 10 times we diluted it. So in that dilution, in this, how many undiluted, how many moles or how many grams or how many moles of the acetic acid is there. From there we can find in 10 milliliter how many moles, so the concentration, mole per liter. Question number 12. The active ingredient in an aspirin tablet is acetyl salicylic acid. In fact, one tablet weighing 5.28 gram dissolved in 50 milliliter of 500 molar, 0.5 molar sodium hydroxide according to the reaction, right? After the reaction has been done, this is reaction 1, okay? This is reaction 1. After the reaction done, then this sodium hydroxide in reaction 2, this HCl and sodium hydroxide was reacted. So, do you have any question on this? Anyone has any question on this? That what are we doing? Why are we doing? Why are we, what do you call it, doing 2 times the neutralization? Anyone has any question? No? Okay, so how many types of titration do we have? Do we know? How many ways a titration can be done? Anyone knows? Want to talk? Anyone? Anybody listening? 2 ways, Bernice. Oh, is that question mark? So you are not sure, huh? If you are not sure, then why are not asking question then? Okay. So here, once again, we see that if we want to visualize this, what is happening here, that is that salicylic acid, okay, we put it in a conical flask. Okay, let's say it's a conical flask, whatever my drawing it is. This is a salicylic acid in the conical flask, okay, and I put sodium hydroxide in it. I put sodium hydroxide in it, excess amount of sodium hydroxide. I do not measure that I'm adding 10 or 15 milliliter. Let's say I'm adding 20 milliliter. I don't require 20 milliliter, but I am adding to be more sure that this acetyl salicylic acid, this acid, although it's I mean not strong acid, weak acid. So it is totally neutralized by this base of sodium hydroxide. That's why I am adding excess amount of sodium hydroxide. Why do I have to excess? Because this acetyl salicylic acid that is inside the aspirin tablet, it is bound with many other things. All right, it is bound with many other binders and other stuff, so that to make it a tablet. Not 100% of that thing, the white tablet that we see is the active ingredient. Okay, there are some other things inside. Altogether makes the tablet. So, but I don't want to know altogether. I just want to know how many salicylic acid, acetyl salicylic acid are there. But since there are other ingredients, if I just do a straight titration, I do just grind it and do the titration this way, I will not get the accurate result, because this active ingredient is being trapped or bound to some other things. All right, they are trapped, or they are not getting contact with the acid or base and not having the reaction. All right, but still it feel like it is having already the reaction is done, but actually it hasn't. So that is why, to make sure that all the salicylic acid reacts, I am putting excess amount, that I know that I will not need this many, but I am still putting this much. But with one condition, that I know the concentration of the sodium hydroxide solution. All right, I know the concentration of the sodium hydroxide solution, and from that concentration and the amount I add, the volume I added, 10, 20 milliliter or whatever, I know the number of moles of sodium hydroxide I have added here, right? So although I do not know the salicylic acid number of moles or anything, but I know the concentration, number of moles of sodium hydroxide. Now, after the reaction has been done, after some time, I stir it, I swirl it, I allow it to mix for some time, and then I believe that all this salicylic acid has now came out of the binder or some other stuff from the tablet, and then reacted together with sodium hydroxide and neutralized, because this is an acid, so sodium hydroxide will neutralize this. Now I know that there is no much salicylic acid inside. I am starting to add HCl in here. So this one, now I am adding HCl. And the good thing is I also know the HCl concentration. So that I add, and from here, the reaction ratio, I know that's 1:1 reaction. So I find X volume of HCl was required to neutralize this excess sodium hydroxide. The excess amount of sodium hydroxide was neutralized by X amount of, or X volume of HCl. X volume of HCl, that means this volume molar HCl, and this is the volume of HCl. So from there we know the number of moles of HCl, and this number of mole of HCl is exactly same number of moles of the excess amount of sodium hydroxide that did not react or did not need to be reacted. Right? So here the leftover sodium hydroxide, after being neutralized by this salicylic acid, was then neutralized by this HCl, and it was this amount. It was this amount. So I know the number of moles of HCl, and then it reacted with sodium hydroxide. From there I can find out how much excess sodium hydroxide was there. Left, and the excess amount I found was, let's say, Y, and from this Y, or I found out the excess amount of sodium hydroxide was Y, that was left, but this left Y was, I know that how much I added sodium hydroxide, right? This is the number of moles of sodium hydroxide I added. So from there, let's say this is A. This is A. So if I deduct this Y minus this A, this is A, I will get the how many moles of salicylic acid was there so that it reacted. Right? So this is called back titration, that we neutralize and then come back again and do the titration. So this is called back titration. So is there any question? Is this clear? All right. I hope that is clear. Nobody. Okay. So, and from this we found it to be 26.9. The answer is 26.9. All right. So question number 13. Any question? Yes. 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 Initial minus excess. Yes. Back titration. Okay. So question number 13. It says that an impure sample of anhydrous sodium carbonate was analyzed as follows. Sodium carbonate, remember. Several 1 gram sample of the impure mixture was weighed out into separate conical flasks, and about 20 milliliter of distilled water was added to it. The mixture were stirred, and then 4 drops of acid-base indicator were added to each of the flask. These were then standardized against hydrochloric acid concentration of 0.1542 mole per liter according to the reaction. 3 concordant was found to be this. The percentage purity of sodium carbonate was, what is with the percentage of purity of sodium carbonate? We know this reaction is 1:2 ratio. This is the stoichiometric ratio 1:2. And from here, we find the average. How do we find? How I think you already know. So we just sum it up. We just sum it up and then divide by 3. We just sum it up and divide by 3. So I will get, I don't know what volume I will get, but I will get some volume. Okay. Let me check what's the volume here. So it is 21.28, right? It's 21.28. The volume is 21.28. Okay, so this is the milliliter. Is milliliter, and then I have this amount of hydrochloric acid, and the concentration is this. So number of moles I can easily find. From there I will find the number of moles of a sodium carbonate, because 1:2 reaction. So if I have X moles of HCl, I would have 1/2 of X sodium carbonate, right? So from there, I find that the sodium carbonate is, I'm getting the number of moles of sodium carbonate. Let's say that, okay, whatever the number of moles of sodium carbonate we get, if we just multiply it with the number of molar mass of sodium carbonate, that is 106, right? If we multiply it with molar mass or molecular weight of sodium carbonate, that is 106. I multiply this one with the number of moles of sodium carbonate, then I will get the mass of sodium carbonate. Mass of sodium carbonate, and that is the mass in 1 gram sample. So the mass of the sample over the total mass, right? Over the total mass, whatever the mass I get, whatever the mass I get this over the total mass, that is 1 gram, and times 100%. So that would be the answer for this. And it's turned out this is answer B. Question number 14. Any questions so far? No. Oh. Any question? No. Okay. Where is it? Oh. So question number 14. Some household cloudy ammonia in which the active ingredient is ammonia, all right, in aqueous form, of course, not in gaseous form, is to be analyzed for its ammonia content by a direct volumetric analysis using standard solution of HCl of molarity 0.1010 mole per liter. The label on the ammonia states that the label on the bottle of ammonia states that the concentration of ammonia present is 5% weight by volume. The equation for the reaction is ammonia plus HCl is ammonium chloride. Okay, so that a 20 milliliter aliquot of the ammonia solution will require a titer of the acid of about 20 milliliter. By what factor must the cloudy ammonia be diluted for the analysis? Now it is in a reverse way, the question is asked that it's always asked that 5% ammonia was there, then how many grams? It is a reverse. So we understand it is already says that it is 5% weight by volume ratio, right? It already, this is the clue we have, and we are using HCl to titrate, and with the concentration of 0.1 molar, so that 20 milliliter of ammonia solution will require titrate about, so, and 20 milliliter of the acid, so this 20 milliliter acid times 0.1 is, that is the number of moles for HCl that we already understood, that 2.02 moles, number of moles will be, 20 milliliter, it should be in liter, right? That's why I say so high, so big. 0.002 moles of HCl will be used, and I am taking 20 milliliter of ammonia as well, ammonia NH3, 20 milliliter of ammonia as well I'm taking, all right? Okay, so now since it is 5 weight by volume percentage, right? Ammonia present, that means in 20 milliliter, how many gram of ammonia will be there? So 5 weight percentage means 5 gram in 100 milliliter. In 100 milliliter, this is the weight percentage, weight by volume percentage, or 5 kg in 100 kg, 100 liters, sorry. Okay, so in this way we find out that the volume of the mass of sodium ammonia is 5% ammonia mass will be this is the 5 gram in 100 milliliter of this solution. But since it is 1:1 reaction, here, so this number of moles will be in the same number of moles for ammonia. It will be the same number of moles in ammonia. So we find the 0.002, right? 0.002 or 02 moles of HCl is equal to 0.00 moles of ammonia. But from there, we see that ammonia has, we already know the ammonia molar mass of ammonia is 17. Ammonia is 17, so okay, let's say it's multiplying with the 17, and then we get the mass of ammonia. If we find the number of moles, and then I'm repeating it for a long time, many times. I hope that it is already, you are used to it, right? That number of moles, if we find, just multiply with the molar mass, and then we find we find the mass. All right, we find the mass of the thing. So here we find it, the gram of the ammonia, and that will be how many gram times 0.17, 0.0343, 0.0343. This is the gram of ammonia we have in the sample, and it says that it is 5 weight percentage, that means 5 gram in 100 gram is already here that we see is 5 gram in 100 gram, right? So the concentration of the dilute ammonia will be that 0.0302, that is the 0.03 that we are showing. What is it? What's happening? Okay, so what I was telling. Okay, so this is the 5% of that, and since I have the mass of ammonia is 0.0343 gram, all right, this mass is in 20 milliliter of the solution. This is in 20 milliliter solution, 0.0343 in 20 milliliter of the solution. So now I want to know, the question is asking to what percentage was it diluted? To what percentage was it diluted? If it is, to know what percentage was it diluted, I need to know that in 5 gram, out of 5 gram, that is 100 milliliter, how many in 20 milliliter is how many gram should be if 5 gram is there. All right, so 5 gram of ammonia per 100 milliliter of the solution, and the concentration of the diluted ammonia will be this gram that we see that 0.0343 gram. All right, and if we multiply with the 5 gram, and then we'll find that ammonia in 100 milliliter of water, or 100 milliliter of the sample, diluted sample. So from there we see that 5 gram times 0.03 0.0343, right? 0.0343 times 5, and that means they are both are in 100. I mean, this is the amount of ammonia in 100 milliliter of the solution. So it will be 0.17, 0.1717, 0.1717, something like that. 1717. So from this 0.1717, right, 5 gram was made to 0.1717. Okay, 5 gram was made to 0.1717 gram, and that is why we know that if we divide 5 over this 1717, that means we know that it is almost 29% diluted, right? Any question? Gabriel, how do we know how the product solution is 100% milliliter? It is volume, weight by volume percentage, okay? Total volume mass over volume times 100%. This is the weight by volume percentage. Or how many gram in 100 milliliter? Gram in 100 milliliter. That is the weight by volume percentage as well, right? So if we know that how many gram I am dissolving in 100 milliliter of the solution, that is the weight by volume percentage, okay? Just like weight by weight percent means gram over 100 gram. So it is gram over 100 milliliter because it's volume, right? Question number 15. The active ingredient in a certain toilet cleaner that claims to remove lime scale and rust in hydrochloric acid is hydrochloric acid of approximate concentration 3 mole per liter. To analyze this toilet cleaner, a quality control chemist first delivered a 10 milliliter alcohol of the toilet cleaner into a 250 milliliter volumetric flask, then made up the dilution solution, okay? Then she titrated 20 milliliter aggregate of this diluted solution against standard sodium hydroxide solution of concentration 0.1044 mole per liter. The expected titer would be approximately how many? What is the volume of the titer we would be needed to neutralize this solution? So it is again question, what do you call it, titration question, and from there HCl and sodium hydroxide, right? It's 1:1 reaction. So if we know the number of moles of sodium hydroxide is given, of course we can know from 20 milliliter and 0.104, right? So from here we can find the number of moles of sodium hydroxide, and from there we can also find the number of moles of HCl. From here, since we find the HCl, the volume of, the number of moles of HCl, and then in 10 milliliter, how to, it is 25 times diluted, right? It's 25 times diluted, and let me check once again. Yeah, it's 25 times diluted, but number of moles of sodium hydroxide and HCl will be the same. So the volume of sodium hydroxide, I'm looking for I'm looking for the concentration of the HCl. So the volume of the sodium hydroxide will be needed to neutralize this is N over C, because N equals C into V, right? So if we want to know the volume, it will be N over C, and from there we can find it is 23 milliliter. So it's 23 milliliter, and yeah. Again, you can do is N equals C into V as well. Sorry, C1, V1, C2, V2 as well. And from there, you will find the number of moles. From that number of moles, you can come back to this, how many milliliter you will be needed. So this is question number 15. Any other question you have? I'm not going to go through all these past examination questions. I think there are some quite easy things. Acid and base I just discussed or explained about it. He says that 3 criteria, right? State 3 criteria. Any question? No. This question asked 1B, anhydrous sodium carbonate is used to as a primary standard to standardize a hydrochloric acid. 3 criteria is asked that so when it mentioned or points out the 3 criteria, you should so please write 1, 2, 3, point out 3 and then write to get the full marks. If you just write blah 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 thing, maybe you will miss some points, right? So it's better to be neat and clean. So primary standard will be those who high molecular mass, stable, do not not hygroscopic, and known molar mass, known formula. Those are question 1C. A chemist is required to make up accurately 500 milliliter of 0.05 mole per liter standard solution from anhydrous sodium carbonate, right? Anhydrous sodium carbonate and mass of anhydrous sodium carbonate required to prepare the standard solution. So you find the number of moles, and then from there number of moles you find the mass of this anhydrous sodium. Anhydrous, does anyone know what is anhydrous? Can anybody tell me what is anhydrous? Type. Can? What is anhydrous? Yes, thank you. No water. In the molecule, there will be no water, right? So sodium carbonate, is it? Sodium carbonate, so it will be just Na2CO3. All right, so this is the sodium carbonate. If it is hydrous, then maybe there will be water molecule. I mean, it will be water molecule inside in the with it, and then how many moles of in 1 mole it will be, or how many parts of the water will be with this 1 part of it will be specified. Sometimes it just say X, and this X varies sometimes. So following the reaction, you have to, maybe you are lucky here, or these students were lucky here that there were no, the reaction was given. Probably you will have to write your own equation, and then you have to balance it out. Only then you can find the number of moles and those things. This should be okay by now because you are doing it, and this is the number titer. So let's say that I don't know what is the volume it will be. So let's say that you are taking this one and this one and this one. So then this tick, you think that these 3 are the closest to all of these three are very close, so you want to take these three to do the average, and this is a little bit up or down, high or low, so you don't want to take it, so then just tick at the bottom or wherever it is, just tick that you show that you have taken these three. And this is the same thing that we have done. So basically this is it for today. Anyone has any question? Anyone has any question? No? Have you taken a look or have you searched anything? Okay, I consider that you don't have any question. Let me take the attendance quickly. Let's see first who are there. Adelaide, you are here. Are you here, Adelaide? Yes, okay. Okay, hold on. It's easy for me. Okay, Angel, can you talk? I cannot look at. Thank you. Then Bernice, yeah, Bernice was talking. Who is Bernice?
Here.
Thank you. Brandon Young.
Here.
Let me find where is your name. Okay. Brandon, you are in the morning, right? Yeah.
Really, I'm not sure.
You are in, anyway, I think you are in the morning session. Anyway, no problem. If you want to come in the morning or afternoon, it's up to you. It depends on your time. I don't mind.
Okay.
Brian Key.
Yes, sir.
Carlot.
Yes, sir.
Where is your name? Okay. Xiang Wei Tio, are you here?
Yes.
Rizvi. Hao Liangsun.
Here.
Gwenda.
Here.
Do I pronounce your name correct? Gwenda?
Yes.
Okay.
Gwenda.
All right.
Yeah.
Temi?
Here.
Yu Chen Chung?
Here.
Calvin?
Here.
Intimisha? Intambu?
Here.
Do I pronounce your name correctly? How do you spell it? Pronounce your name?
Intimation Tambu, yeah.
Intimisha Intambu. Okay. Yaman? Hello, Yaman Z Huang Te.
Here.
Sophia?
Here.
Marjan? Okay. Jia Keki?
Yeah.
Chen Liang Teo.
Here.
Megan.
Here.
Jia Wei Sung.
Here.
Okay. Darren Kwan.
Here.
Jun Hyun Chia. Jun Hyun Chia. No. Jun Hyun Chia, no. Absent. Okay. Shankar Roy. Shankar Roy. Absent. Lian Sunti.
Here.
Darren John.
Here.
Lik Seng Tan. Lik Sen Tan. Absent. Jonathan.
Yes.
Gabriel.
Yes, sir.
Tania Radzwa.
Yes, sir.
Okay. Brandon William.
Here.
Okay, so Nishi, Nishi was here. Nishi in the morning. Resby. I saw you in the morning, then you left. Okay, so now, have you searched anything about the project? Have you Googled it at least?
I did a bit about my topic.
Sorry?
I have at least Googled about my topic.
Oh, that's very good. So what is your topic?
Hydroelectricity, I think.
Okay, so you think you have already Googled it. You be sure, go and check what is the topic on for your group, and then yes, try to Google. At least first thing that we do is Google it, and then because we cannot take everything from Google, because Google is not a reviewed, it's not that trustworthy, because anybody can say anything on the Google. So it is, you cannot just quote that somebody said. It has to be from trustworthy sources. What are the trustworthy sources? Those are books first. Second is journal, the what do you call it, the journals are scientific journals, right? Those are the trustworthy thing. And some university or the project websites as well. Then also from the IP, okay. Okay, so IP, that means intellectual property. So all those things are very, those which has been reviewed, which has, the scientific committee has said, okay, we reviewed it, is good, it is okay. Then those are the thing that we call this trustworthy. So Google is good to get an overview, just an idea that what it is, how does it look like, how does it operate. Those are things are good from the Google, but you need to, or university websites, sometimes university, they do some project on these, or they do some research on these, so they have some information. Not all university have all those things. Some university have some of these. So yeah, Brandon, he does a very good thing that he actually Googled it at the beginning, so that he's aware of what is hydroelectricity power, how does it work, and okay. So anyone else, anybody, anyone other, any other topic, anyone wants to talk or any question? No, haven't started yet. So at the beginning, let's say I start from the beginning. What is the first group is solar, right? The solar is actually the harnessing the energy from the sun, right? So this is solar energy, harnessing the energy from the sun. But those who are in Malaysia now, in Kuching, in fact, they know that it has been raining for last few days. There are not much sun, intermittent sun only. So there is a drawback. You don't get always the sun. Another thing is, we do not, our research is not at that level that we can convert 100% of the solar energy to electrical energy. Cannot, not yet. Only a small fraction. You have to go and check what is the fraction. Right? Every day research is done. The research is renewed. New information are coming out. New results are coming out every year, every month. So it is. And it is also important where the solar panel can we set. We cannot set it to that North Pole or South Pole, because where there is no sun, or the country where it is always cloudy, or always there is foggy, or most of the time is cloudy or foggy. We cannot send it, set it up. Another thing is what? Lik Seng Tan, you are here. I think I make you present already. Oh, that's why I say Tokla. Okay, so I was talking about solar. Oh, one consequences for solar is that if we want to set it up, if we want to set it up, what will happen is I need a lot of space, because it is not 100% conversion. I need a lot of space to set it up. The solar panel, I have to put the solar panel, right? And if I want to put the solar panel, where do I put it? I have to put in a way that it is quite flat, good, so that it can get the maximum time, the sun, the rays of the sun from almost, like, let's say that a 0 angle to that another 0, 180 angle to another 180 angle. But till the sunrise to sunsets, it gets the solar energy. We would try to set in some places like that. In that case, we have to maybe we need to, those countries do not have much land, maybe they have to sacrifice their population, their locality, or their agricultural farm. That is one of the consequences. Another consequence is because the sun not at night, but I need the light at night, the energy at night. So how do I, what do you call it, get the light at night? That means I have to store the energy. So storage is another problem for the solar. How can we overcome it? Or what is the best way that we can make these all things more improved or efficient? So this is solar. The second one in my list is tidal wave. Tidal wave is renewable energy, but it is because in our ocean, we constantly, every time, all the moment we have wave, right? We don't need to create anything. We don't need to provide anything in the ocean. The ocean itself, because of the geography and the fluid, it will always have this tide, like this, the wave or tide. So because when this is a wave, that means there is a energy, potential energy or kinetic energy, whatever, there will be at some point inside. So we can harness that energy and convert it mechanically to electrical energy. Tidal wave. And tidal wave is most of the time during the near the shore or beach, we do not have very high tide, right? We do not have very high tide. We have low tide, low wave, not a very high wave. If we want to have the high wave and constant wave, we have to go into the deeper into the sea. Probably, I'm not sure. Probably you have to go. You guys go and check where you can get the high tide. And also this. Also, the high tide, during the high tide, water rise up, then low tide, water goes down. So I can make, it's about two times a day. So I can make the power for 12 hours, and then the next 12 hours I cannot make the power. So that means I spend a lot, but I'm not getting that much output. Probably that is another thing. Okay, so and for tidal wave also, that you have to bring the energy from the source to the locality. So you have to have a very grid of the power. Hydropower and tidal energy similar but not same thing. Hydropower, the tidal energy or the wave is naturally occurring in the sea, and that we are taking it. For the hydropower, we are enclaving the water, right? We are enclaving the water in a place, and then we are forcing the water to go through a very narrow channel so that it can rotate a generator. Okay, it can rotate a generator, and then the electricity produced. It is good. It is quite efficient as well, but the downside is you have to have a very big reservoir, and it should not be in the flat land. Okay, and when you reserve the water, your ecosystem gets some problem. I'm not telling you everything, but you need to find it out. Okay. Okay, I'm coming to your question a bit. I've finished first. So this is hydropower, and what else? Oh, the good side of the hydropower is hydropower can be used to generate a huge amount of power. If we look at the Malaysia or Sarawak in particular, they have big hydropower dams and hydropower generation, electric generator here also. Biodiesel or biofuel. Biodiesel is a renewable energy in a sense that it is produced from the waste oil or waste product. All right, waste product. It can be animal byproduct, or it can be plant byproduct. So since it is plant grows every year, and then we get the fruit from it every year, but plant is there. So that is why we call it renewable energy. And from there we can produce the biodiesel. How do we produce the biodiesel? We need to do the some kind of reaction, esterification reaction, to produce from that fat. Actually, the biodiesel will be produced from fat. The source is fat or oils. Okay, oils or fats. So those fat, we convert it to biodiesel by using some catalyst. Using some reaction, through some reaction, and that reaction is called esterification reaction. And there are different types, different ways to do the esterification reaction, and then we use also catalyst. So the biodiesel is a good thing. It is diesel has, the diesel and the fuel, petrol and diesel, it causes a lot of environmental problem, right? It is a greenhouse gas, producing greenhouse gas. It is producing a lot of soot and particles that is bad for human health. but biodiesel is free from that, right? Biodiesel is free from that. Biodiesel does not produce that much. But another problem biodiesel has is it is not probably, I mean, you need to go and search. The thing is, does not produce as much power as the diesel does. That is one drawback. And for biodiesel, the engine, I mean, the engine, if we use biodiesel, the engine probably does not function that good as well. So there is one downside. And now the research is coming out that biodiesel, if we even do the biodiesel, the gas that is coming out, it is also has some consequence. It is not very good. I mean, it is not free from everything. It has some consequences. Okay, geothermal energy. Geothermal energy is one of the opportunities for producing electricity is by using the natural water vapor, all right, the natural water vapor. But for this, okay, how it happens? Under the surface of the earth that we are sitting, that we are making our buildings or whatever, we make the roads, this is surface, right? Underneath the surface of this earth, deep inside, at the core, our earth is still very hot. It is magma inside. It is so hot that nothing can be solid there. Everything is liquid, viscous liquid. So it's called magma there. It's very hot, more than 3000 degrees centigrade. So what happens is when we, so the deeper we go, the more hot it becomes, right? So at some point when there is, I mean, at some places, and this geographically, some places, some part is more hot than other parts. So when at this hot part, the water goes, somehow water goes there, the water becomes vapor, right? Water becomes vapor. So this water vapor is actually a good thing that we can use to generate electricity by using the, I mean, by moving that generator, by moving that generator. Actually, the biodiesel will also be something, right? We will be using to make the water vapor, and that water vapor will, I mean, rotate the generator to produce electricity. So this geothermal energy, the problem is not everywhere. Only some places in the world there are some geothermal. I mean, it is nearer to the surface. If it is like 5 kilometers inside, you have to dig. It is not very feasible. All right, it is not very feasible that you dig 5 kilometers and then you have to add a lot of water inside so that the water will come out as a vapor, and then it will steam, actually steam, yeah, not vapor, steam, and then rotate the steam engine. So there are some places that if even 200-300 meters, if we dig or make the hole, we can get to that more than 100 degrees centigrade, where we just need for make the water vapor, make water steam. Okay, so this is another problem for geothermal, that is not availability. Wind power, I don't think that I need to talk much about the wind power. The wind power is the windmills. I think everyone has seen the fan that moves, right? The fan that rotates, not moves, that rotates that way, clockwise, anti-clockwise, I don't know what way. Hello? Can you hear now? Oh my God. I don't know how it became muted, but the thing is, have you heard that I was talking about the geothermal? Okay, then, okay. I don't know how it becomes mute. I didn't touch anything. Okay, good, thank you, until wind. Okay, so wind is that wind power, I mean, the long, tall installment or step, I mean, we make some, yeah, fan type thing and then it keeps rotating. That is the wind turbine. That is the wind turbine, and the wind turbine is for harnessing the energy of wind energy to produce the electricity. When it rotates, it also rotates a generator, right? It rotates the generator and then it generates the electricity. For wind power, this is very, I mean, this is zero emission actually. It is no emission at all. I mean, we are just using the wind to rotate the blade. So this is very good. The problem is, its installment is very expensive. You know, the installment is very expensive because you have to make 30-40 meters high, right? You have to make 30 meters like that high, and then the blades are also specifically you have to produce, and the generator you have to, so this is a bit expensive. And then if you have to where do we get the you have to install it where there is high wind, right? Where there is high wind coming. Where do we have high wind? We have high wind in the sea or in the coastal area or near the valley of the near the valley of the two mountain, those things. The problem is if we want to set it in the sea, then there is a very the construction is a very big problem. And of course, the corrosion is another problem, maintenance, because the seawater is very much corrosive, and the seawater, the wind that coming out from the sea is also very corrosive for the metals. And if we want to put it, I mean, in the valley, right, between the two mountain or hills, there is another consequence that you have to make it to certain height in between the you have to make it to certain height. If you do not make it to certain height, it will not rotate. So that is the other problem. So there are consequences, there are I mean, good and bad, and pros and cons on both sides and all these things. Okay, and did I miss anything? Okay, so biomass that is produced from the fossils. Okay, so that the fossil that not fossils actually, the organic waste. Okay, the organic waste, that means the our agricultural product that we throw, that we don't need to use it, we just throw it. From there, we make it mulch, and from there, the mulch, we can produce some kind of fuel. Okay, after it is being conditioned, that mulch, after being conditioned, we can treat it with, let's say, acid or base or whatever, to make it more flammable. More, not flammable, how to say it, is a more better fuel, to be better fuel. So we dry it and then we make it like, how do you call it, solid thing, although it is not solid, it's maybe rotten powdery form, but after being dried, after being conditioned, after being washed with acid or base or whatever, and then it is dried and then pressed it to make it a solid type of a rod or fuel type things. Okay, so that is one of the another best or another very good example for those country who does not have the natural resources. They do not have wind. I mean, maybe they do not have coastal area, right? They don't have the hydroelectricity because they do not have enough water, hydroelectricity, and they cannot afford to go for this solar because solar is expensive. So, and geothermal, of course. No. So this is also a very good example or very good option for those people, those are living on those type of part of the world. So now this biomass is the good thing. I like biomass because it is very cheap. It is very inexpensive. It is very inexpensive. It is easy to prepare, and everybody in the society can be benefited directly, right? Directly. That means everybody in the society can take a participation, I mean, can have a participation in that manufacturing, production, and to get the benefit from it. So that's what I like from the biomass. Now I'm going for the nuclear energy. Nuclear energy is nowadays there is a lot of, I mean, where should I start? Okay, nuclear energy is very promising. Of course, it's very promising. It's a huge energy that is sitting inside a small quantity of the reactive materials. That what are the materials that we use for? That is heavy material that can go under fission, right? That can go under fission. So those type of these uranium, plutonium, all those things are, I mean, heavy elements that can go and undergo nuclear fusion. So they can produce, I mean, during that fusion, they can produce a lot of heat, heavy heat they can produce. So when they are producing this heavy heat, this heat is then used to rotate the turbine, I mean, to make the steam from the water and rotate the turbine. And from that rotating the turbine, it is producing the electricity. So this is the nuclear rod or nuclear, this uranium or plutonium or polonium, whatever you are using. Actually, uranium and plutonium, this is the two things are used for nuclear power reactor. So this thing, what was I saying? Oh, so they are actually are used as a fuel. Okay, they are also a fuel that being used, and there are some certain grades that if you just take the uranium from the shop or then start to cannot, you have to enrich it. Enrich means you have to make it to that level, purify it so that it can go under fusion reaction. So there is a challenge for this. The drawbacks are the danger. The world has already seen many nuclear disaster by now already, and it started from Hiroshima, then Nagasaki, then Chernobyl, right, in Russia, long time ago, and then in Japan, the recent past, we saw it in Fukushima. There was a problem in the nuclear reactor, and then Japan shut down. So there is, I mean, pros and cons in both sides, but this is an enormous energy. If we can make it safe, right? If we can make it safe, then it is an enormous energy. Okay, so I'm going to see the question now. No water, no water, no water. Bernice, for the project, is it like doing research or we need to design our own prototype? Okay, Lixen Singh. Okay, I get your point. Okay, for Bernice, yeah, it is kind of doing research together, all of your, that's why I'm saying that it's impossible to do alone, okay? And if you do not participate in the, okay, let me, by the way, tell you that if you are not participating in the group project, group work, timely manner, and if your group member tell me and I find out that it is actually you are not participating, then probably you have to do alone. I'm telling everyone, probably you have to do alone, because if no group wants you, then you are on your own. So you have to submit on the whole thing. So please go and sit together, talk together, discuss together. This is good for all of you. You will learn more, and also you will learn how to, in the professional life, how to do work in your team. Okay. My throat. So the project is, yeah, it is like a group research doing. The thing is, you will find the information, okay? You will find the information from the published work. Published work means from the internet platform, from books, from your peers, from other universities. So yeah, that is the thing that you will learn. Megan, sir, sorry, I'm still not clear about what we are expect to prepare for this project. Is it like to create a prototype of the machine, or a background and impact of energy, or everything? You have to, okay, first thing, you have to do the presentation. Okay, you have to do the presentation. Please go and check the marking scheme that I already uploaded yesterday, and under week 2 module. Okay, there is a project under something named group project, I think. So there is what you have to do is everything up there. The marking scheme, where, how many mark you have, everything is there. Okay. And yes, you have to do the presentation on through the like this. Okay, on I mentioned when is it, and also what is that? Everyone has to talk. So you will show your thing, what you like. Somebody is doing the introduction, somebody is doing the methodology or how this thing has been done. Somebody is showing us the result. Somebody is showing us the discussion, or you, I mean, it's up to you which part you want to represent and discuss about. It's up to you guys. You can discuss and then fix among yourself that which part who wants to present. But everyone, all of 4 or 5 of you in the group, everyone has to do this presentation. And from now on, like you are sitting together, you can you have to keep a gadget. Okay, you have to keep a scrapbook. Scrapbook means this is my scrapbook. I don't know whether you can see. I don't know whether you can see. This is my scrapbook. Okay, this is nothing. I mean, I'm coming there. Okay, this is nothing concrete thing, but this is my scrapbook. I scribble it here, I write it, and then if I do not like it, I cancel it. So this is my scrapbook. So in this way, you will keep a scrapbook, and it will be better if you keep a scrapbook, because since it is online, you are not in the uni together. So if it will be better if you keep open, if you open what is that called, that Google Doc, right? It's called Google Doc. So all 5 or 4 of you in a group can contribute there. I want to see that. Okay, you have to submit that too at the end, that or I mean with the date, that you put the date that or this week, week 1, week 3, week 5, we sit together. That was the thing. There is no mark on the scrapbook, but I want to see that you submitted a scrapbook, 1 per group. In that scrapbook, what you plan to do, not necessarily you will do, but maybe your plan, your brainstorming thing that you came out, your ideas came out, or you just cancel it that you didn't work out. So those are the things in the scrapbook should be. Okay, so you should keep a scrapbook. And okay, what is expected? So I want you to find out that what is that project. Yes, scrapbook should be submitted as a PDF. Afterwards, after presentation, you should submit your presentation slides as well to me, 1 per group. I will let that one will come later, so I will talk that. I don't want to talk now. I will tell later. Okay, so the thing is, if you go and see in the if you go and see the marking scheme for the project, you will know what to do. Okay, introduction, then literature, methodology, result and discussions, all those things. It is nicely pointed out that what you should do, how many marks it for what. Okay. Do I mute again? No? Okay. Okay. So Megan, this is the thing, one thing, and a prototype of a machine. Yes, I would like to know, see a prototype that you are doing a small, what to say that, hydrothermal, hydropower, tidal wave, like this, a small thing. But since we cannot do it in uni, if it is possible, then do a model, computer model maybe. This can be a drawing, a design, or if you are good in computer, it is not necessarily. Okay, I'm telling you, it's not necessary that you do a 3D model, but if you are good in computer, then you can do a 3D model. Or you can, otherwise you can do a drawing nicely telling us that what do you think. Brandon Williams, so most of the nuclear disasters are in Japan. Yeah, it looks like one is self-created, another one was foreign country created in Japan. So, yeah. Bernice, should the scrapbook be submitted? Yeah, in PDF. Is it compulsory to come up with a model? It's not compulsory, but you get it gives a good vibe to the presentation as well for you too. Oh no, sorry, the model, design of the model, yes. Design of the model, yes. That means online, a drawing of the model, yes. But 3D drawing, no. 3D, no. But just a drawing is yes. Brian and Rizvi, prototype is important and compulsory, but 3D drawing is not. Okay, just a drawing, simple drawing is okay as well. Anyway, I think when you will be presenting, you will see, you will also, it will be necessary for you to. So making a prototype is not, okay, I already said. Anyone else has any other question? No? Okay, so you see you on, is the criteria out yet? What criteria, Brian? No need to type, just talk. We're just discussing, right?
For the project criteria, is it out yet?
How do you mean the marking scheme? Yeah.
Yes, yes.
Marking scheme, you go and find under the week 2 module.
Okay. Thank you, sir.
Resby, I took the attendance, but you were not there. Where did you go? Okay. Okay, no problem. Megan, what is the minimum research question expected from us? The more, the merrier. Okay. The more you can give, the better. That's why I'm saying, sit together, think, then you'll see a lot of question and answer is coming out. Gabriel, how to do the model? Once again, I'm telling you that the model is just a drawing. Show me a drawing, but 3D drawing is not necessary. Okay. So less than 5 also can. Yeah. I mean, how many of you in a group all together? If you have 5 person in a group, 5. If you have 4 person in a group, then 4. Jonathan, yeah, no report, just presentation. And scrapbook, of course. Are we using PowerPoint representation? Yes. Any other question, anyone? Yeah, presenting live, Megan, presenting live through these MS Teams. Oh, then scrapbook be kind of like report will do. You can make it, but I want to see with dates, that under that date, how you sit together, all of you, and then talk and discuss, found some idea, rejected some idea, all those things. That is the scrapbook. Yes, you show your face. Why not? But don't worry, you don't have to have the formal dress. It's just casual dress. Oh. I think we can use our phones, right, as webcam, or can present from our webcam, through our webcam, phone, MS Teams from the phones. Nah, cannot. This is a live presentation. People will ask you questions. They want to know what you do. So how pre-recorded can, Don't worry, it will be fun. I believe me, it will be fun. Always, I miss this presentation. Actually, last semester also could not do, but last semester, it was so fun. Fun and awkward. Now, not awkward. I'm saying it's nothing. Nobody else is here, right? We are here. We know each other. Maybe there will be other lecturers. If they want to come, then if my colleagues say that I want to listen, then I cannot say no to them. But I will let you know if anybody is coming or not. But I will take this opportunity to tell you that on week 6th, there will be one guest lecturer from our chemical engineering faculty department to talk about this renewable energy, okay? Because we have different field of research. So I will call someone who is doing research in this renewable energy, and they know a lot about it. So they will come online, of course, and then will share his or her experience to you guys. You can ask any question. You can ask as many questions you want, okay, to him or her. No worries, no problem. If we have time, he will or she will answer the question. So this is you can ask any question, as many questions as you want. I will announce this as well on the Canvas. Yeah, announcement. Okay. Imma asked if he still used the predictable. I don't understand, Brian. Imma asked if he still used the periodic table. I don't know. I don't understand what your question. Yeah. So since we can ask questions, so what? I will ask if he still uses periodic table. Of course, everyone does. I have one behind me, a periodic table. Sir, do we need to do the list of yes, it is important. Do the list of references, yes. Thank you for this bringing awareness. Brian is in his everyday life as chemical engineer. Yes, it's a good question you ask. I don't know. Probably. What salt, how much salt he is eating. Will it submit to Turnitin? No, because they don't have any reports, so no submission. But don't do the copy. I will check. So if I see it's copy, then you will lose marks. So is there a minimum number of resources that we need to use? No, but resources means the references. I guess you say references. There is no minimum, but you cannot just use one, and you know that if you just use 1 or 5 or just like that, then and somebody is using 20, so you are already lost some marks here. Not lost the marks, but you already lost some information that we know that you already have read 5 papers and somebody read 20 papers and books. So of course he or she knows more. So Okay, so is there any other question? Anyone else? Slide limit, don't make it too long. If it's too long, then it will be boring. That's why I say that maximum 15 minutes, each group, maximum 15 minutes. Anyone, anything else? No need to submit the articles. Okay, I'm guessing that you don't have any other questions, so I'll see you on Monday. Take care, have a nice weekend, stay safe. Bye-bye.